tell you how many times that you're going to use that base as a factor in your multiplication problem. So let's get that written down. So again, if we were to go ahead and write this out in expanded form or our standard form, it would be 5 times 5 times 5. I'll tell you right now, as much as you guys swear up and down that you know what an exponent is, I guarantee at one point somebody in the class is going to make the mistake and tell me that 5 to the third power is 15. Happens every single year. It happened this morning. Doesn't mean anything, just move past it and keep in mind that if it was supposed to be 5 times 15, it wouldn't be a small little tiny number in the corner. This is a representation that's different than multiplication, okay? Now, how you phrase it. Every single number has an exponent, even if it doesn't have one written. If it's not written, what's the exponent? 1. Just like before, if we say, hey, every single variable has a coefficient, if it's not written, it's a 1. It's the same thing with an exponent. If I were to just write 5, it has an exponent. The exponent is a 1. And this would just be represented as 5 to the first power. That's how we read our powers. Now there are two very special powers, 5 to the second and 5 to the third. They're special because they have some other way to be able to phrase it. The more common way of phrasing this is 5 squared. So if you hear me say 5 squared, that means 5 and the exponent is a 2, or 5 to the second power. And then if you have 5 and the exponent is a 3, that's 5 cubed. So you got squared and you've got cubed for those exponents. And again, you can always say, your base to this power, first power, second power, third power, 50th power. It doesn't matter. You can always say something power, but you need to be aware that if we say squared or cubed, that's what it means. And again, those are the only two that have two ways to be able to phrase it. Everything after that is always going to be to the blank power. Now you have different formats of which you can write. You've got a standard format, which is also known in our expanded form. So if I say standard or expanded form, then that means that I'm writing it out as a longhand multiplication, like 6 times 6 times 6 times 6. If I say exponential form, that means I'm writing it as a power, a base, and an exponent. So instead of 6 times 6 times 6 times 6, it would be 6 and then the fourth power, because the 6 is repeated 4 times. So I want you to go ahead and write the following in exponential form. All right, who can tell me how do we write number 1 in exponential form? Nathaniel? Yeah, 4 to the 5th power. So just 4 to the 5th power. We have the 4 is being repeated 5 separate times. So 4 is your base and the exponent is 5. So 4 to the 5th power would be the final answer for that one. What about for problem number? Do you have a question, Connor?
Oh, no, I'm raising my hand.
Okay, so go ahead, Connor. What did you get for number 2?
So this one was an educated guess, but 3 to the 3 squared 6.
Very good. It's a good educated guess. So a lot of people in first academic, they thought, okay, well, I can only have one base. But you have 2 different numbers that are happening here. That means you have 2 different bases, 2 different exponents. The 3 is being repeated twice. So that's 3 squared times, then you've got your, here's my green. You've got your 6 that's being repeated 3 times, so it'd be 6 cubed. 3 squared times 6 cubed would be your final answer if you're leaving it in exponential form. Okay? Yeah, go ahead, Davis. Very good. 8 cubed, x cubed. 8 cubed and x cubed. Your 8 occurs 3 times, so 8 cubed. And then your x is occurring 3 times, so x cubed. 8 cubed, x cubed. Yes. Oh, go ahead. Oh, no. Austin had his hand up, and that's what I was saying. Go ahead, too. I'm going to say no. Rashawn, did you have something different? Still the same thing. There's something that's missing.
Oh. Okay. Negative 2 x. Oh, wait, negative.
Well, those aren't x's. Those are multiplications. Okay, so here's a.
Negative.
I'm going to stop you. Well, Kenson, what do you think? No? So here's the problem with this, and you have to be very deliberate when you're answering it. What? Nope. So you have to be very deliberate when you're writing problems like this. How many of you wrote it, and be honest, how many of you wrote it as just -2 and then cubed? That's how you wrote it. So this would actually be considered to be the wrong way of writing it. The reason being, when you write it this way, this implies that only the 2 is raised to the 3rd power and not the negative. In order to make sure that the negative is included, what do you need to put around it? Parentheses. So whenever you're showcasing that there is a multiplication that is occurring of negatives, you got to put parentheses around the negatives. Here's why. Take a look at a problem. So I'm going to go ahead and flip to the next page. So I'm going to put a big star by number 4. So if we were to take a look at a problem like -4 to the 2nd power compared to -4 in parentheses to the 2nd power, these are not equal to each other. They're not equivalent to each other. The reason being, again, -4 without the parentheses being raised to the 2nd power implies that you are only doing 4 times 4. The negative just happens to be on the outside. It's only the 4 that's repeatedly being multiplied, not the negative. So if I were to do that, what would my final answer be? -16. Whereas here, because I am including the negative inside the parentheses, that means that negative is also part of that repetitive multiplication. So this is actually -4 times -4, which gives you what?
16.
Positive 16. These are not equal to each other. Not including that parentheses completely changes the result of the answer. So you have to be very aware of that. This is also true Not just with negatives, but what else do you think it might be true with? Well, not positives. Positives, it's okay. But what other kind of number or type of number do you think you might need to put parentheses around? Because if you don't, it would change the result. A fraction. Not a decimal, but a fraction. Very good. So if you were to take a look at our next example, so problem 5, if I have 2/3 times 2/3 times 2/3, when I'm writing this in exponential form, I have to make sure that I put it in parentheses because it's the 2/3, the entire thing, that's repeatedly being multiplied. 2/3 to the third power, so putting that in parentheses. If I didn't, so let's make a little note beside here, without your parentheses, if I wrote it as 2/3 and I put to the third power, that third power would only belong to which value? The top, the numerator, the 2. So this really, the way that that's written, really represents 2 times 2 times 2, all of it over 3. It's not the same thing. So that inclusion of your parentheses is very important. You need to make sure that you do it. Without those parentheses, you will get the problem wrong. Okay? Then you're going to have some problems in which you're going to need to evaluate. Evaluate meaning basically solve it. Okay? That's just another way of saying work it all the way out until you get a final answer. Not just rewrite it, but work it out. So if I were to give you -5 in parentheses to the 4th power, what would that equal? Rashawn. Ethan. 625. Very good. So what you're doing here is you're multiplying -5 times -5, which is 25, times -5, which is -125, times another -5, which is a positive 625. Here's a nice rule of thumb. If your exponent is even, your answer should be positive. If you've got a negative base, but your exponent is an even number, you will get a positive result. If your base is negative and your exponent is odd, you'll get a negative answer for your result. Okay? Do you have a question, Alicia? No. Yeah. There is such thing as negative exponents. See, not a stupid question at all or a stupid observation. Yes, you will have negative exponents, and we're going to get to that next week. And there is such thing as 0 exponents. And there is such thing as fractional exponents. Exponents can be any type of rational number, yes. All right. So 6/7 raised to the 2nd power. What is that going to equal? 6/7, the whole thing raised to the 2nd power. What is that going to equal? Have you guys put your hands down because you've already answered before? No way. Nope, not taking that as an answer. Come on. I'm very glad that you said that because that's the same mistake that was said last period as well. 12/14, what mistake did he make? Diego? No, that's not it. Davis. He multiplied by 2 instead of multiplying by itself. You got to be careful. Now, here's a nice thing to know. When it is an exponent, 6/7, is that simplified? Yes. 6/7 is simplified. So that means when you're multiplying 6/7 times 6/7 as well, that answer will already be simplified also. You won't have to worry about simplifying it because 6 over 7 can't be simplified. And when you're multiplying it by another 6 over 7, those can't be simplified. That means the whole thing is simplified already. So that would give you 36 over 49 because you're doing 6 times 6 over 7 times 7. So 36 over 49, and that's as simplified as it's going to get. Now, 6/7 second power, no parentheses. What is that going to equal? Nathaniel? 36 over 7 is correct. Again, this means that it's just 6 times 6 on top, but the 7 does not have the exponent included to it. So that's 36 over 7. That is your simplest form. We're going to go ahead and start leaving our fractions as improper just so that we're ready for next semester's unit on functions where you're going to have slope. And slope is a fraction form, whether it's proper or improper. No more switching them to mixed numbers. Okay. All right, number 4. Did you have questions, sweetie? Yeah. Yeah, you could have the denominator with even a different exponent. I could say it's 6 to the second power over 7 to the fourth power. That would be different. Okay? All right. A to the second plus B to the fourth. And A is going to be equivalent to -3. B is going to be equivalent to 5. I want you to evaluate that expression. That's pre. That's pre. Do you have a question? Huh? No. We're only focusing on rational numbers. Howard, what'd you get? Very good. Okay. Don't be so surprised. You're smart. Come on. All right. A squared. Quiet. You're replacing the A with a -3, but remember, -3 is now going to have to go inside parentheses. You're wanting to include that negative. So it's -3 to the second power. And guys, again, if you use your calculator and you type -3 to the second power without parentheses, it's going to give you what as the answer? No.
You said it was 0. Yeah, that's why I said 0.
Now, let me show you. So I'm going to steal the calculator that's on the floor. What? Number 22. Oh. All right, taking a look here. Let me show you. Quiet. Again, if I type in -3, here. I'm trying to get it focused. There we go. All right, so if I type in -3 and I raise it to the second power, it's going to give me -9, even though we know -3 times -3 is +9 because I didn't put the parentheses around it. Like I said, if you don't put parentheses around it, that exponent only belongs to the number and not the integer, okay? You have to put parentheses around the -3, then you can go ahead and do the exponent, okay? Now, -3 times -3 is going to give you a +9. Please stop talking. You're being rude. Then you're going to change the B value to a 5. So this is now going to be 5 to the fourth power. 5 to the fourth power, as we already discussed before, is 625. And all you have to do is add between them. And that's going to give you your final answer of 634. Your homework for tonight. Stop complaining or I'll increase it. Your homework is out of the workbook, so I've already printed the pages and I've already removed the problems I don't want you doing. Make sure you get it done. It's ready to turn in and check tomorrow.